Geometry AV2 Lesson 3 on volume of prisms. We're going to do a little bit of talk about some vocabulary involving prisms, as well as solve some problems involving volume, word problems and otherwise. So let's go ahead and get started. Alright, so a quick review of prisms. As you can see here, I've got a prism. I got two bases. Both of those bases are pentagons, and I'd like to just kind of go about each of these colored items within the diagram and talk about each. So in a prism, of course, we've got two bases. We can see that the bases are pentagons in this case. So we would call the green space base, as well as this base up here. So these two should be congruent in shape and size, of course. So that's our base. Staying with this idea of the base, let's talk about the purple and blue segments that we've got here. The blue segment we call the apothem. Okay, the purple segment. And the apothem, of course, is unique to the regular polygons. The purple segment is not unique to regular polygons. It's actually unique to everything, in that it is the side length, right, or an edge of the base. So we could call this a base, edge, or side length. Okay, we refer to that typically as S, right? So the apothem, of course, is lowercase a. The side length is S, and the number of sides we would refer to as N. Our orange space here, I think this is orange. Let's try it. We're going to call a lateral face. Okay. We use lateral faces when talking about surface area, but not when we talk about volume. So we're not going to have to worry about the lateral face in our calculations in this lesson. But we do want to work with what's called a lateral edge. Okay, lateral edge. I know my spelling isn't great there. But we're actually going to refer to this as the height of the prism. Okay, height of the prism. All right, which will take on the variable capital H. Okay, going back to the base there, we're gonna call this the we're gonna use the variable capital B, and specifically calling that the area of the base. Those two are going to those two variables are going to be important today in our lesson. So capital B and capital H. Let's get into this. Okay, so volume is the measure of the amount of space contained in a solid. Volume is measured in cubic units. So you can imagine in both of these prisms that you see here that we're filling the prism up with cubes. And of course, we want to know how many cubic units it would take to fill up, right, or to contain in, it could be contained in that space. So for example, let's take example A here, and I'm going to refer to this space as the base. Okay, so if I wanted the area of the base, I would take a 2 times a 3. So the area of the base is going to equal 6. The height of this prism, can't recall what color we used. I'll go, I think we went red. Yeah, I think it was red. The height is going to be the distance between the bases. You can see that the other base would be on the other side. I could give a little perspective here. Okay, the red length would be the height. Of course, the red length we can identify as 4. Okay, you could count up, counting even those cubes that you can't see within this visual, but we would get 24, right? The volume in this case would be 24 centimeters cubed. Now, how would we build that based on a formula? Well, to find the volume, we would take the area of the base times the height. Okay, so I'm going to translate that down here. You can see that if capital B is the area of the base, or right rectangular prism, and H is the height of the solid, then the formula, of course, would be the same here. It would be capital B, area of the base, times the height of the prism. So in example B, to find the volume, in this case I could use really whatever dimension I want as the area of the base, but I'm going to choose to use, in this case, just to show the difference here, I'll call this my base, which of course would refer to this space down here as my other base. I'm going to find the area of the base by taking, what would that be? 3 times 12. So the area of the base here would be 3 times 12, which is 36. And the height, of course, would be the length, or the distance between the bases, which would be 8. So, of course, we're going to take our formula, newly acquired, and find the volume by taking 36 times 8. So 36 times 8, not sure what that comes out to be, but if I got my calculator handy, I can sure find out quick. And I get 288 centimeters to the third power, right? Cubic. All right, let's look at another example. Okay, volume of the prism. Again, you can use whatever you'd like as the base or the area of the base. I'm going to, just to mix it up, look at this surface as the base. Of course, this is a right rectangular prism. This length here will be my height. I'm going to identify 2 as the height or the distance between the bases. And of course, this would be a 3 by 4. So the area of my base would be 3 times 4. And of course, the height would be 2. So our volume would be 12 times 2, giving us 24 cubic centimeters. Pretty basic example. Let's get to some that are more complex. All right, so in dealing with right rectangular prisms, things seem to kind of show up in our visible a little bit easier. Now with regards to, for example, here I've got a non-rectangular prism. This is a triangular prism, which refers to our base within the name. Our base here is a triangle. So I'm going to look at my triangle here, here, and here, as well as down at the bottom. Right, those are my 2 bases. So when I find the volume, I haven't changed, and I will not change my formula. I still want to find the area of the base, and I want to find the area, the height. Now the area of the base is going to be calculated just slightly differently. If I translate my lengths, this length here would be 8, this length over here would be 5. When finding the area of a triangle, of course, the area of the base is going to be 1/2 base times height. Now notice the difference here. I've got a lowercase b. This represents the base of the base. And capital B represents the area of the base. All right, so let's find the area of the base using the lengths provided. Of course, 5 and 8, those are perpendicular to each other, which is great, which means that they would represent the base and the height. So the area of the base would be 20 centimeters squared. Now I'm going to leave it in that form, 20. And look at the height. And the height is the distance between the bases. Of course, in this case would be 9. So our volume would be 20 times 9, which comes out to be 180 centimeters cubed. Okay, so if B is the area of the base of a right prism, or cylinder for that matter, and H is the height, then the formula for volume, again, we're just reiterating it, would be area of the base times the height. All right, let's continue with another example. All right, so I'd like to challenge you to determine what the different variables will be here. First of all, what the shape of the base is and what the height would be. Go ahead and pause the video, try to identify those, come back, and we'll talk about it. Okay, so you've paused the video. Let's talk about volume. Okay, no change in the formula. Okay, were you able to identify the height? I hope so. The height is the distance between the bases, which in this case is 10. So our height will be 10 centimeters. Okay, to find the area of the base, I got to determine the shape of the base, and the shape of the base in this case is a trapezoid. Okay, so we've got a trapezoidal prism, which tells us the shape of the base within the name. All right, so what I've got to do is I've got to find the area of the base. Well, the area of a trapezoid is 1/2 base 1 plus base 2 times the height. Now this is the height of the trapezoid. Height of the trapezoid. Okay, whereas the red H is the height of the prism. Okay, these are the bases of the trapezoid. Bases of the base or of the trapezoid. Whereas capital B, yet again, is the area of the base. All right, let's do a calculation. Capital B will be 1/2. My two bases are the lengths of the sides that are parallel to each other. So I see an 8 on the upper length, and I see a 12 on the lower length. The height is the distance between those two parallel sides, which will be 4. So the area of the base will be 1/2 of 20 times 4, which comes out to be, looks like 40. Okay, so I've got my height, which was 10. I've got the area of the base, which is 40. I'm going to multiply them together, and I get a nice number of 400 centimeters cubed. All right, let's continue. Pause the video, identify the base shape, identify the different components, the height, and make your calculation. Okay, you're back. And the volume, of course, is the area of the base times the height. The base shape, in this case, is a triangle. So the area of the base will equal 1/2 the base length of the base times the height of the base. In this case, I can see I got a nice right angle there. So this right triangular prism has a triangle for its base length, or its base shape. The base of the triangle I could call 3, and the height I could call 8. Now, with that, I could alternate those, right? I could call the base of the triangle 8 and the height 3, regardless, doesn't matter. So here are the shapes of my two bases. Clearly I can see that the distance between them, which would be capital H, is 10, and so I'm going to make my calculation for capital B, which is 1/2 of 24, which will be 12, and I'm going to multiply those together. So I'm going to bring them down utilizing the values for capital B and capital H, which will be 12 times 10. So the volume in this case is 120 centimeters cubed. Okay, let's take this to another level and look at a problem that I would consider an extension style problem. Okay, now let's find the volume of the prism shown below. Now this prism is a right rectangular prism. However, you can see here that there's been a chunk cut out of it. Okay, imagine like a sheet cake and you wanted that middle piece, so you cut it right out of there. Okay, so first of all, let's find the volume of the entire prism. So let's imagine there's nothing cut out of it. Okay, so I'd find the area of the base times the height. All right, so the area of the base, let's consider the bottom. All right, the base, or the area of the base. So you can see that we would have a length and a width of 3x and 5x. So I'm going to calculate the area of the base by taking a 3x times 5x. Now the reason I consider this an extension problem is because now we're talking in general terms involving x. So 3 times 5 is 15, and x times x is x squared. Okay, let's look at the height. The height, of course, would be the distance between the bases. So the height in this case would be x units. Oops, that wasn't my best. There we go. That's a little better. So our height in this case is going to be x. Okay, so the volume of the entire, prior to cutting out the center of the cake, volume of the entire prism would be 15x squared times x. So if you know anything about rules or laws of exponents, we know that we would take this 2 and this 1, right, that's x to the first, and we would add those together when we multiply. So we would get 15x cubed. Now let's take and find the volume of the piece that is extracted. Okay, so now I'm just specifically going to look at this as my base, and yet again, at the same time, the same height, right? Because I'm going to cut all the way down to the plate or the platter or whatever it might be. All right, so you can see the base of the piece that was cut out there. All right, so the area of the base now, it looks like this length here was x, and this length right here is 2x. So I'm going to take the area of the base of the piece that's being cut out and multiply it by the same height. Okay, so the volume of the piece that is extracted is going to be area of the base. Let's calculate that on the side. That'll be length times width, which gives me 2x squared. And the height, of course, is the same as it was before of the entire sheet of cake. Okay, so we're going to take 2x squared. We're going to multiply it by x, and the volume of the piece that was extracted for the birthday boy or girl would be 2x cubed. Now, the volume of what is left for everybody else at the party is going to be our first volume minus our second volume. All right, so let's do this. So it's the entire cake minus the piece of cake. So I'm going to take 15x cubed. Fortunately for us, these are like terms. Minus 2x cubed. So the volume of what is left over is going to be 13x cubed units cubed. There you have it. That's an extension. All right, that would be a very challenging R3, possibly even R4 material. All right, guys, that's it for today. Lesson 3 on Unit 6, Volume of Prisms. Have a great day. See you in the next video.